Hey everyone, welcome back to Show Your Work. My name's Jake. Today I want to talk about order of operations, what was taught to me as please excuse my dear Aunt Sally. These days you'll see it as PEMDAS, GEMDAS, or BEDMAS even. I just want to break down why we need this, a couple suggestions on how to teach it, a few nuances that come from it, and at the end we're going to use everything we've learned to solve this big problem here. So let's get into it. So first of all, why do we need order of ops in the first place? So this is to eliminate confusions that come when we try to do multiple calculations in a row, like very simply 2 plus 3 times 4. So you'll notice that there's ambiguity here because we could treat this in two different ways if we didn't have order of ops. The first way would just be to go left to right and say I do, 2 plus 3, well, that equals 6, or I'm sorry, that equals 5. And then multiply that by 4, well, that equals 20. But if instead I multiplied 3 times 4 first, getting 12, then added the 2, well, that gets me 14. So since these aren't the same, we need to have a rule to decide what comes first, what comes second. So our rule is we multiply before we add. If we wanted to add first before we multiply, then we would put these parentheses here. And it's kind of asking the question, what is being multiplied by 4 here? Is it just the 3, or is it the 3 plus 2? Similarly, if we have exponents involved, let's say we have 4 times 3 squared. The order we do this matters. If I do 4 times 3 first, getting 12, and then square that, that gets me to 144. Versus if I square the 3 first and do 4 times 9, well, that gets me 36. Vastly different answers. So again, we need to have a rule. We say we do the exponents first. And we're asking, what is being squared? Is it just this 3? Or do we want to square the whole 3 times 4? So again, we just look at what's attached to the little square. It's just the 3 in this case. If we wanted to do 3 times 4 squared, then we need these parentheses here. So the parentheses tell us that what is being squared, not just the 3, but everything inside the parentheses. Just like over here, when we were asking what is being multiplied times 4, is it just the 3? No, it's everything inside the parentheses. So the parentheses tell us where to start, and that's why they are at the top of our list here. So let's get into this list and break it down a little bit. So you'll notice first that we have these three different words for our first step: parentheses, grouping, or brackets. And this comes from the three different ways you might have seen this taught. Uh, PEMDAS, or please excuse my dear Aunt Sally, is what I was taught, P standing for parentheses. GEMDAS, with G standing for grouping, tends to be the more commonly form taught these days. And BEDMAS tends to be a bit more of a European thing. But the point is they all mean the exact same thing. Parentheses and brackets both have the exact same function. Sometimes we might want to use both in a very complicated equation, just to emphasize what's on the outside, what's on the inside. Brackets tend to be used for the larger outer functions, and then parentheses for smaller inner functions. Something like that. It's just a way to nest our groupings just a little bit more explicitly. And I think groupings is kind of a good way to go these days because it includes not just parentheses and brackets, but all forms of groupings. So something like 5 minus 2 divided by 3 plus 1, this fraction sign or this division sign also means it's denoting a grouping. Everything on top is assumed to be a group, and everything on bottom is assumed to be a group. So even without parentheses here, these are implied, that the top is its own group and the bottom is its own group, meaning we need to do those two groups before we do that final division. So that's the order. First, we look at all these types of groupings, whether it's above fractions, in parentheses, in brackets. We want to do inside those first. Then we look at all of our exponents. We take care of those. And then let's talk about these last two sections here. And you'll notice that I've grouped them up a little bit into multiplication and division, and then addition and subtraction. So as we discovered before, multiplication division comes before addition and subtraction. But now here's kind of a subtle point. What is generally taught these days is that within each of these, multiplication and division, we need to go left to right. Now this is technically not true, and I want to talk about this a little bit. When it comes to multiplication and division, purely mathematically, these all happen at the same time. And crucially, we are allowed to switch the order around however we want, as long as we're careful about what division means. So let me explain what I mean by this. Suppose we have something like 2 times 3 divided by 4 times 6. Now, typically they say we have to do this left to right, but that's not true, as long as we recognize that division is actually just a form of multiplication. And I want to start changing our thoughts to this. When I say division is just multiplication, what do I mean when I say something is divided by 4? Well, that means the same thing as it's multiplied by its reciprocal. Multiply by a fourth. Dividing by 2 is the same thing as multiplying by a half. So as long as we can think in these terms, then all of these calculations can be done in any order we want. And this is kind of a fundamental fact about algebra and in lots of different math systems. The fact that A times B is equal to B times A. This is the commutative property. And it's crucial that we can do this, and it helps us to do it. The confusion comes when we need to recognize that division is actually just multiplication by the reciprocal. So if all of this is just 2 times 3, and it says divided by 4, so times a fourth, times 6, now we can do this in any order. Let's try just left to right. Well, that's 2 times 3, which is 6, divided by 4. And see here, this is why I want to be able to rearrange this, because now I have 6 times a fourth, and then times 6. Do I want to do this left to right? What's 6 times a fourth? Well, that's 6 over 4, sure, but now we have a fraction in there that doesn't have a nice whole number answer. Wouldn't it be nicer to be able to do 6 times 6 to get 36? Now we can multiply that by a fourth and get 9. But maybe you say, oh, that's not the same thing. We rearranged the order. Well, let's do 6 over 4 times 6. Still get the same thing, 36 over 4, which equals 9. And let's do a different order. Maybe we wanted to do 2 divided by 4 times 6 times 3. Well, that's a half times 6 times 3. Half of 6 is 3 times 3 is 9. So the point is, no matter what order we go, we can rearrange multiplication and division. however we want. Same thing with addition and subtraction, as long as we have the caveat of what is subtraction of just adding the opposite. So A minus B is actually just addition as long as we recognize that this is not the number B, this is the number negative B. This is A plus negative B. And as long as we do that, no matter how complicated it gets, I can rearrange these as long as I keep the sign right in front of the number. So this number here is not 5, this is negative 5. And if there's no symbol in front of the number, we assume it to be positive. So this is a positive 2. And then we can say, let's put the plus 4, and then the minus 3, and then the plus 6. And we can do this whatever order makes sense to us. Negative 5 plus 2, now we're at negative 3. Plus 4, well, that'll get us to 1. Minus 3, well, that's negative 2. Plus 6, there's 4. But we could do it in another way. Maybe we want to do all the positives first. 6 plus 4 plus 2. Well, that'll get us to 12, and then we can do all the negatives. Minus 3, minus 5. That's 9 minus 5, and that's 4. So why do they tell us we have to do this left to right when it's not actually true? Again, this is a very big fact of algebra that A plus B is equal to B plus A. So why are they telling us left to right? The reason is, if you're just using your calculator to just put this whole thing in and calculate it, that's what your calculator does. Your calculator treats these things as left to right. And sometimes that can cause mistakes. If we're neglecting our parentheses, we need to be sure to tell the calculator exactly what we want it to do. So when they say left to right, that's not really a mathematical fact. That's just teaching you to learn more like the calculator. All right, let's put all of this together and see if we can use it to solve this big problem right here. So just for reference, I'm going to write our GEMDAS over here, groupings, exponents, multiplication, division, addition, subtraction. So looking for groupings first. Let's take a look at what all of our groupings are. Big obvious one. We have this big division symbol, this big fraction. That means everything on the top is a group and everything on the bottom is a group. So I need to do everything inside these two big groups first before I do that final fraction division operation. So we have to go inside. Let's look at the top group first. Within this top group, I still need to follow the same GEMDAS. So I'm within a group, but now I got to look for even further groupings. And I see this one right here in these brackets, negative 10 minus negative 6. So I want to do that group first. You can think about that just by itself. Negative 10 minus negative 6. So when you see this minus sign, just like before, we can kind of think of that as adding the opposite of this. Opposite just means if it's plus, the opposite is negative. If it's negative, the opposite is positive. So negative 10 minus a negative 6 is plus the opposite of negative 6, which is positive 6. Negative 10 plus 6 is negative 4. So in my first grouping up here, I just want to replace what's inside this group with negative 4. And I just want to do the one step for now. So we're going to keep everything else as is. This 13 plus negative 3 squared, plus 4 times negative 3, plus 1 minus, and then this grouping we just solved is negative 4. All right, let's look for groupings on the bottom. Right away at the start, we have this 4 plus 5 in brackets. That's its own little grouping. We can solve that as 9. Now we have a division symbol. So what are we dividing here? We're dividing this first group and this second group. So we'll keep the symbol here for now. And let's see if we can solve inside this second group. And notice within this second group, there's another grouping. So we need to do this inner grouping first. We're thinking inside to outside. So since I have this inner grouping to solve first, let's leave the rest of it alone for the moment. We have 4 squared minus 3 squared times. What is in this grouping? 4 minus 3? That's just 1. Still have this minus 8. Still have that bracket. And plus 12. All right, so we did the first layer. Just the innermost parentheses is what we found. So let's keep going. Looking at this top group again. Within each of the parentheses, or brackets, I now am down to just the single number, negative 3 here, negative 3 here, negative 4 here. So we can consider the insides of those brackets solved at this point. So now I look at the next level down. We did all of our groupings in the top. Now I look for exponents. And we only have one right here. So let's go ahead and solve that exponent. So that is negative 3 squared. Negative 3 squared is positive 9. And that's the only step I did on top for this. There was only one exponent, so we'll just leave everything else the same for now. With the exception of this, we can kind of clean this up a bit. We have now plus, oh, did I lose a 1 here? There, look at that. There's supposed to be a 1 right there that we lost. Good catch. So we're looking at plus 1 minus negative 4. So we can keep our plus 1. And again, what is minus a negative 4? That means plus 4. All right, let's go back to the bottom now. We have some more groupings to deal with. Now we can finish taking care of this second group here in our division. So I'm doing 4 squared minus 3 squared times 1, which is just 3 squared, minus 8. Maybe I'll do that over here. 4 squared minus 3 squared minus 8. That's 16 minus 9 minus 8. That's 7 minus 8. That's negative 1. So right in here, we put negative 1, close those brackets, and there's still this plus 12 here. All right, we're getting there. So looking at the top now, we are down to just mostly addition, with the exception of there's this one multiplication right in the middle here, 4 times negative 3. So we're going to do that multiplication first, and then all the addition. This becomes 13 plus 9 minus 12 plus 1 plus 4. Now we can do all of that together in whatever order makes sense to us. So I'm going to take 9 plus 1 is 10, minus 12, negative 2, plus 13, positive 11, plus 4 is 15. And you could do that in a few different ways. Maybe we should do 13 minus 12 is 1, plus 9 is 10, plus 1 is 11, plus 4 is 15. Again, doesn't matter. Now let's look at the bottom. We have a division and an addition. This division needs to come first. So 9 divided by -1 is -9. Then we can add the 12, -9 plus 12, or if it's easier, 12 minus 9 is equal to 3. So final step, we've done all the grouping on top, all the grouping on bottom. Last step is this big grouped division, and we get our final answer of 5. So thanks for watching. I hope you enjoyed this video, and we'll see you next time. Hey, thanks again for watching. I hope you enjoyed that video. Just a quick reminder, if you're interested in getting tutoring for yourself, you can email me at mathteacherjake@gmail.com. You can also find me on Fiverr. I'll put the links in the description for the video below. And also, if you guys have any suggestions on what kind of topics you'd like me to cover, please leave it in the comments below, and I will get around to your topic as soon as I can. Thanks so much for joining us, and we'll see you next time.